Our next speaker is Sam Ramji of Sailplane, who also helped quite a bit to bring this meetup together, so thank you. And give it up for Sam.
All right. How's everybody doing? I'll be brief, I'll be bright, I'll be gone. Questionably on the bright, but 2 out of 3 ain't bad. Good to see a bunch of folks that I know and good to meet a bunch of people I don't know. So I'm going to talk briefly about fine-tuning in practice. And I have huge passion for open source. You're about to find out why. So frontier models are the tower cranes of AI, right? We live in environments built by them, and we look up at them, and we wonder, like, oh my God, how did they build GPT-4o1? Could I possibly touch that? Could I possibly change it, right? How do we make our own? This is kind of the core spirit and driver of open source. How do we start to experiment? Because I would like my tower crane to look a little different. I don't want to take one of the off-the-shelf ones. So interestingly, it takes a crane to build a crane, right? You start with the mobile crane, and you start to build the foundation for the tower crane. Anybody here ever seen a tower crane get built? So it's really interesting because once you get the tower crane set up from the mobile crane, the tower crane can build itself. It can actually make itself higher and elevate. So this is the path that we all have available to us as open source model practitioners. So why start with a small crane? I mean, apart from the fact that small cranes are incredibly cute. It's where open source thrives. So the previous speaker just talked about the 8-node H100 80 gig box. I use those on GCP at Sailplane, and those are $1.50 a minute, $90 a day, $2,000. $90 an hour, $2,000 a day, $60,000 a month, unless you get committed use discounts, and then who actually knows how long you're going to use that. So if you could have something that just fit on one H100, then you can really start to learn and explore. So the small crane, where we get to try new things on our own machine, on some piece of commodity hardware, something that we can afford to not trade off what we're going to eat versus experimenting. For me, it's a series, right? The first crane is this base model, right? You could grab Llama 3, Llama 3.1. You can grab DeepSeek. The algorithm, what is it that we want to reproduce? Is there a great paper that we've found? I'll talk about our inspiration in a moment. And then the resulting trajectories. We can collect all of these open source trajectories from open source algorithms, and that is the first crane. And the second crane is the fine-tuned model. Now that we have all those trajectories, all created openly, all available in the open, we can now start to explore what is the algorithm that's provoking our curiosity. And then we get the resulting trajectories. Again, if you go and look for a video of how tower cranes get built and see them build themselves and get higher, you'll see that once you start fine-tuning and you improve your trajectories, let's say you've got a benchmark against which you can only score 20%. If you feed your trajectories back into the next fine-tuning run, you may be able to get 30%. You may be able to get 40%. Where does that improvement run out? Only you will know based on what you're super curious about. Because what I believe is that if we take these models and we focus them on the domain we care about, we can outperform any general purpose model. So that is a really exciting moment for me in open source. So exploring what could we build with our own tower cranes. We could build cities and towns and whatever that we want rather than be stuck in the walled gardens of OpenAI or Anthropic or anybody else who's shipping giant models where all of the different parts of it are stuffed together. Can you remove the instruction tuning from GPT-4o? No. Can you retrain the base model without changing the instruction tuning for GPT-4? No, you can't. What if you want to fuck around and find out? Right? Well, we at Sailplane are trying to push the limits of hierarchical planning. We think that actor-critic networks are very promising for this. A good, high-performing, low-cost actor-critic network builds on the same transformer basis that you have for the normal large language models, but you build on a common backbone. You build 2 heads. The normal backbone is an actor, predict next token. The critic is an improver. You could think of it as a built-in re-ranker that can look at those plans coming out of the actor and say, out of those 10 plans you just generated, The ninth one is far better. So just proceed with that, right? So as we start to think about the future of powerful agents and agentic AI, it's all about being able to play between an actor and a critic, I believe, very rapidly, maybe take 10 turns. Maybe a year from now, we'll be talking about taking 1,000 turns. I got to attend the Mistral 2 launch event yesterday, and Jensen Huang spoke in person. And he said, look, I see a world where you're going to take 1,000 turns of reasoning and planning before you return an answer to a person. So we're probably going to need to figure our own path out. So the question is, can we get state-of-the-art results from open models? What we did was we thought math as a data set, math as a challenge from Berkeley is really interesting for reasoning, right? It's beyond the grade school math problems. It's not polluted. It's a great challenge. It will fall over soon too. But a team in China built something called DeepSeek. DeepSeek math does reasonably well by itself without fine-tuning. And then a team created something called Alpha Math. It borrows Google's AlphaZero concept of a limited supervision or self-supervised learning. And they then published the Alpha Math data set. You can get all this at Hugging Face. What we were able to do then was to take that exact same DeepSeek Math 7B, and we did supervised fine-tuning with our actor-critic model. We were able to get in and change the brains of the model. Now, again, it's important here because it's only a 7 billion parameter model. So that means we can stuff it into a small environment and we can learn a lot. Fine-tuning, by the way, takes about 10 times the headroom that inference takes. So when you start thinking about 7B, multiply it by 10, that's how much resource you're going to need. Think about fine-tuning Llama 3.1405B. That's our next goal. It's going to cost us $500,000 to run a single fine-tune, just in terms of the flops you need on H100s. So it's nice to start small, build a small crane, iterate. We get to play with our own beam search approach to see if we can get improved step-by-step reasoning. And then we get more trajectories. That's not an acronym, that's just emphasis. More trajectories is how you get to the next level, so you can keep making your crane higher. The results we got were really promising. Building on this team from China's original base, we used the REACT pattern to be able to get a 33.2 score on math. Now, that's not an impressive score, right? GPT-4, before 401 came out, was getting 70. But it's a base, non-fine-tuned score. As soon as we deployed our actor-critic fine-tuning, using the same REACT pattern, we're able to see an improvement up to 50. So that's a huge lift. We then started to mess around with our own Sailplane beam search, and we found we could get it to 61.5. What do these numbers mean if they're not world-class, if they're not state-of-the-art? What they mean to me is directionally, we've now been able to do enough work for free on open models, paying only for the hardware, that we feel fairly confident that we can get someone to make a bet on us and say, we will try giving you $500,000 and see if you could beat GPT-401 with this fine-tuning approach and with this dual-headed actor-critic model. And then we all get to break out, right? We get to share these ideas and we get to play together, right? So to close, I just say, let's help each other build our own tower cranes. Let's keep coming to these meetups. Let's share what we're learning about fine-tuning. Let's share what we're learning about what's difficult. Because with our own fine cranes, we can share the wonder. So thank you very much.